Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilman bin Hamdan and I would like to present our topic which is carbon nanotubes as electrochemical determination of dopamine. First, I'd like to present the abstract of our review article. Dopamine sensors are important tools in biomedical research. Carbon nanotubes are especially promising building blocks for dopamine sensors due to their unique electronic and optical properties. There are two types of carbon nanotubes that are classified according to the number of dopamine layers present in them. Single-walled carbon nanotubes, which consist of single graphene layer with diameter varying between 0.4 and 2 nanometers and usually occurs as hexagonal pad bundles. Multi-walled carbon nanotubes, which comprise of two or more several cylinders each made up of graphene sheets. They can be chemically modified in such a way that biologically relevant molecules can be detected in high sensitivity and selectivity. An example of the kind of modification that can be done is nephron coating of carbon nanotubes. In this review article, we will discuss the type of carbon nanotubes that is best used as a dopamine sensor, the modifications that can be made to enhance the performance of multi-walled carbon nanotubes, and the comparison on the performance between an unmodified carbon nanotubes and modified carbon nanotubes. Keywords for this review article is dopamine sensors, carbon nanotubes, modifications, comparisons, and performance. Now I'd like to present the introduction. Dopamine is a chemical naturally found in the human body which is made from the brain. Dopamine is a hormone and a vital neurotransmitter that plays several important roles in the brain and body. Dopamine detection is of great importance in clinical diagnostic applications. Due to the electroactive nature of dopamine, numerous efforts have been made into electrochemical approaches to develop sensitive and inexpensive devices for rapid detection of dopamine. However, significant challenges are still present, which is limiting the efficiency of traditional electrochemical electrodes and can cause tissue damages. In recent years, carbon nanotubes have been widely used as an electrochemical sensors and biosensor. So there are three objectives of this review project. One of them is to study the classified types of carbon nanotubes that is best used for dopamine detection. Another objective of this review is to study the modifications made to enhance multi-walled carbon nanotubes. And lastly, the objective of this review is to study the comparisons on the performance between an unmodified carbon nanotubes and modified carbon nanotubes. There are two types of carbon nanotubes, which are multi-walled carbon nanotubes and single-walled carbon nanotubes. According to Edgar Nagels, the use of carbon nanotubes has increased in the last 2 decades in electroanalytical applications due to their outstanding structural, electronic, and catalytic properties. According to B.R. Stoner, as a result of the unique electrochemical properties of carbon nanotubes, such as the high activity and kinetics of H-plane-like graphitic sites on the nanotube ends and sidewall defects, they are particularly important structures for electrochemical sensing applications. There are several methods to modify multi-walled carbon nanotubes to improve its performance. According to Himani Sharma, hybrid materials in which carbon nanotubes are blended with some other materials that include metals, semiconductors, and oxides hybrid materials will modify their structure and properties to improve certain applications in various fields. Based on the journal written by Wei Song Zhang, the performance of multi-walled carbon nanotube can be improved through the surface modification of multi-walled carbon nanotubes. Results indicate that surface modifications such as anodic oscillation with the sodium hydroxide electrolyte removes more amorphous carbon, introduces fewer defects, and more oxygen-containing functional group. Finally, according to Liao Wang, multi-walled carbon nanotube has been widely applied to construct electrochemical sensors for the sensitive and selective detection of various analytes owing to its unique physiochemical properties such as high electrical conductivity, fast electron transfer, high chemical stability, large specific area, good biocompatibility, and excellent electrocatalytic activity.
Now I'm going to explain about methodology. Based on this experiment that we reviewed, there is a different way to study the type of carbon nanotube. It is also help us to study the modification made to enhance multi-walled carbon nanotube and to study the comparison on performance of the type and modification made to carbon nanotubes. This experiment answered our objective based on the article that we reviewed June 10, 2017. We used this article to research our mini project, which is carbon nanotubes as electrochemical determination of dopamine. This is a list of material, equipment, and facility that they use: dopamine hydrochloride, uric acid, Nafion polymer solution 5%, acetylene gases, Jobinvion Horbio 800, Shimatsu IM 8000 FTIR spectrometer, MWCNT yarn, AGCL electrode, and platinum mesh. So for the fabrication of multi-wall carbon nanotube MWCNT yarn, the MWCNT forest for fabricating MCWT yarn was grown by chemical vapor deposition using acetylene gas as the carbon particle. And the modification of the multi-wall carbon nanotube yarn to improve the performance, we obtained the MWNT yarn electrode was directly dipped into the Nafion solution for 10 minutes, followed with a drying step in an oven at 60 degrees. And then the physiochemical characterization of multi-wall carbon nanotube nanoyarn. The micro-size MWCNT nanoyarn was tested by Raman spectroscopy and Fourier transform infrared spectroscopy. And lastly, the electrochemical characterization. The 3-electrode system was used for electrochemical performance evaluation, including MWNT yarn was working as working electrode, AGCL as reference electrode, and platinum mesh was counter electrode. PBS at pH 7.4 was the basis electrolyte in all experiments. Thank you.
Now I would like to present the results and analysis based on the experiment. Firstly, the electrochemical performance of pristine multi-wall carbon nanotube and Nafion-coated multi-wall carbon nanotube. The SEM images of figure 1A and 1B of pristine and Nafion-coated multi-wall carbon nanotube yarns showed that the Nafion layer has been successfully coated onto the bundled multi-wall carbon nanotubes. The Nafion-coated multi-wall carbon nanotubes yarn revealed more densely packed filaments in comparison with the pristine multi-wall carbon nanotubes electrode. The difference of electrochemical dopamine detection was clearly shown in figure 1F when the pristine yarn blue line only gave minor current signal response of less than 0.5 microampere, while Nafion-coated multi-wall carbon nanotube yarn, the red line, displayed a dramatic increase in current signal with highly separated peaks of dopamine and uric acid. This improved biosensing performance could be attributed to the negatively charged coating on the multi-wall carbon nanotube yarn. Next, I would like to present the capability of Nafion-coated multi-wall carbon nanotube yarn in detecting concentrations of dopamine. For further investigations, differential pulse volumetry was used to test the capability of Nafion-coated multi-wall carbon nanotube yarn in detecting low concentrations of dopamine. Figure 2B to 2D showed the differential pulse volumetry curves record the target oscillation of dopamine from 0 to 1 micromolarity in a phosphate buffered saline solution containing uric acid and ascorbic acid at 200 micromolarity each. Dopamine oscillation was notable even at a concentration as low as 0.02 micrometer in the presence of 200 micrometer ascorbic acid and 200 micrometer uric acid.
Assalamualaikum, and now I'm going to continue with the presentation today with the discussion part of our study. So, discussion part is divided into two, which is the properties of multi-wall carbon nanotubes and the properties of Nafion as an enhancement to multi-wall carbon nanotubes. So, first of all, the properties of multi-wall carbon nanotubes. First of all, we know that carbon nanotubes has a high tensile strength. Second of all, it is extremely lightweight. Third of all, we know that carbon nanotubes has a very fast electron transfer kinetics. Fourth is carbon nanotubes are very has a high biocompatibility, which helps in protein immobilization. 5. Carbon nanotubes surprisingly has a very large surface area. When it has a larger surface area, meaning that it can increase the rate of detection. 6 is carbon nanotubes are chemically inert. 7 is it is known that carbon nanotubes has a very large number of antibacterial and antifungal properties, which can be used as a protein carrier. This is because it contains exposed functional groups that helps and tremendously very attractive in various biosensors. Next, discussing about the properties of Nafion as an enhancement to multi-wall carbon nanotubes. First of all, what is Nafion? Nafion is a derivative to Teflon. So, for the first property is Nafion is a polymer film that is highly permeable to cations, but is very impermeable to anions. For example, in the range of pH 5.2 to 8.87, ascorbic acid and uric acid exist in an anionic form, and dopamine and serotonin are in a cationic form. So, in this case, the Nafion polymer film will let dopamine and serotonin pass through it without any problem, and will block off the ascorbic acid and the uric acid from passing through the polymer film. Second of all, Nafion polymer films are very good have a very good electrical conductivity. Second of all, it has a very good chemical stability, which means it does not easily react with the surrounding solutions. And fourth, it has a very high biocompatibility, so much that it is widely used as a easily fabricated.
Hi, Assalamualaikum. My name is Muhammad Wafi. In this video, I will talk about conclusion. There are three objectives of this proposal, which is to study the type of carbon nanotubes that is best used as dopamine sensor. The second one is the modification made to enhance carbon nanotubes, and the third one is the comparison on the performance between an unmodified carbon nanotubes and modified carbon nanotubes. The conclusion drawn by first objective is multi-wall carbon nanotubes are mainly used as dopamine sensor instead of single-wall carbon nanotubes, because biosensors based on multi-wall carbon nanotube have shown better reproducibility, sensitivity, reliability, and economy. Another conclusion that been drawn by second and third objective are the improvement of multi-wall carbon nanotubes in biosensing technology makes them more sensitive, specific, and conducive in the detection of analytes such as dopamine. It was proven by article with Algaty 2017 that multi-wall carbon nanotubes that undergoes modification such as Nafion coating has better performance in electrochemical dopamine detection than unmodified multi-wall carbon nanotubes. This is because the multi-wall carbon nanotubes were coated with Nafion, a perfluorosulfonated polymer which is practically impermeable to ascorbic acid and other anionic species, and only slightly responsive to neutral metabolites. thus it becomes selective for the cationic neurotransmitters dopamine and serotonin. The butyl carbon nanotubes was used for determination of dopamine in real biological samples and satisfying results were achieved. These are references that been used by this review article. Thank you.